Imagine you're in a race, but instead of running at a steady pace, you keep getting faster every second. That's uniform acceleration. But how do we calculate it? Let's break it down. Uniform acceleration is also called constant acceleration. It refers to a constant rate of change of velocity over time. This means that an object's velocity changes by the same amount each second. Uniform acceleration is like when you're riding a bike and you keep pedaling faster at the same rate. Imagine you're starting from rest, and every second you get a little bit faster. In the first 1 second, you're moving at 4 meters per second, in 2 seconds at 8 meters per second, in 3 seconds at 12 meters per second, in 4 seconds at 16 meters per second, and so on. That's what uniform acceleration means. Your speed keeps going up by the same amount all the time. Did you know? The fastest land animal, the cheetah, accelerates from 0 to 100 kilometers per hour in just 3 seconds. That's an acceleration of nearly 9.3 meters per second squared, more than double what most sports cars can achieve. To calculate the motion of an object moving with uniform acceleration, the 4 equations are used. The first equation, final velocity, is equal to initial velocity plus acceleration times time. The second equation, displacement, is equal to 1/2 brace, initial velocity plus final velocity brace time. The third equation, displacement, is equal to initial velocity times time plus 1/2 times acceleration times time squared. And the fourth equation, final velocity squared, is equal to initial velocity squared plus 2 times acceleration times displacement. In the equations, v is equal to final velocity, u is equal to initial velocity, s is equal to displacement, or distance traveled, t is equal to time, and a is equal to constant acceleration. Note that the equation to be used is based on the data given. Let's consider some examples. A car from rest accelerates at 4 meters per second squared in 7 seconds. Find its final velocity. From the information given, we're looking for the final velocity. The initial velocity is equal to 0, as objects from rest have 0 velocity. Acceleration is equal to 4 meters per second squared, and time is equal to 7 seconds. With this data, we can use the first equation. V is equal to u plus a t, u is equal to 0, a is equal to 4, and t is equal to 7. 0 plus 4 times 7 gives 28 meters per second as the final velocity of the car. The second example. A jet accelerates uniformly from 15 meters per second to 400 meters per second in 35 seconds. How far has the jet traveled? We're looking for distance. The initial velocity is equal to 15 meters per second. Final velocity is equal to 400 meters per second, and time is equal to 35 seconds. With this data, we can use the second equation is equal to 1/2 brace u plus v brace t. Then 1/2 u is equal to 15, v is equal to 400, and t is equal to 35. This, after computation, gives 762.5 meters as the distance traveled by the jet. The third example. A car is moving on a highway at 20 meters per second. The driver wishes to pass another car and accelerates at 2.5 meters per second squared over a time of 4 seconds. How much distance did the car travel in 4 seconds? We're looking for the distance traveled. The initial velocity is equal to 20 meters per second. Acceleration is equal to 2.5 meters per second squared, and time is equal to 4 seconds. With this data, we can use the third equation. Is equal to ut plus 1/2 at squared. U is equal to 20, t is equal to 4 plus 1/2, a is equal to 2.5, and t is equal to 4 squared. This gives 100 meters as the distance traveled by the car in 4 seconds. The fourth example. A bus from rest travels 50 meters at 4 meters per second squared. What is its final velocity? We're looking for the final velocity. The initial velocity is equal to 0, as objects from rest have 0 initial velocity. The acceleration is equal to 4 meters per second squared, and the distance traveled is equal to 50 meters. With this data, we can use the fourth equation. V squared is equal to u squared plus 2as. U is equal to 0 squared plus 2, a is equal to 4, and s is equal to 50. Then v squared is equal to 400. Square rooting 400 gives 20. So the final velocity of the bus is 20 meters per second. To recap, uniform acceleration, also called constant acceleration, refers to a constant rate of change of velocity over time. To calculate the motion of an object moving with uniform acceleration, the 4 equations are used. Now that you've mastered the equations of uniform acceleration, in the next video, we'll uncover the free-falling objects. Will heavier objects fall faster than a lighter object? Stay tuned. Stay curious.